Photography is the science, art and practice of creating durable images by recording light or other electromagnetic radiation, either electronically by means of an image sensor, or chemically by means of a light-sensitive material such as photographic film. Typically, a lens is used to focus the light reflected or emitted from objects into a real image on the light-sensitive surface inside a camera during a timed exposure. With an electronic image sensor, this produces an electrical charge at each pixel, which is electronically processed and stored in a digital image file for subsequent display or processing. The result with photographic emulsion is an invisible latent image, which is later chemically developed into a visible image, either negative or positive depending on the purpose of the photographic material and the method of processing. A negative image on film is traditionally used to photographically create a positive image on a paper base, known as a print, either by using an enlarger or by contact printing. Photography is employed in many fields of science, manufacturing and business, as well as its more direct uses for art, film and video production, recreational purposes, hobby, and mass communication. Etymology. The word photography was created from the Greek roots phi, omega, tau, micron, sigma, genitive of phi sigma, light, and gamma rho alpha phi eta, representation by means of lines, or drawing, together meaning drawing with light. Several people may have coined the same new term from these roots independently. Hercules Florence, a French painter and inventor living in Campinas, Brazil, used the French form of the word photography in private notes which a Brazilian photography historian believes were written in 1834. Johann von Meggar, a Berlin astronomer, is credited in a 1932 German history of photography as having used it in an article published on 25 February 1839 in the German newspaper Vossische Zeitung. Both of these claims are now widely reported, but apparently neither has ever been independently confirmed as beyond reasonable doubt. Credit has traditionally been given to Sir John Herschel both for coining the word and for introducing it to the public. His uses of it in private correspondence prior to the 25th of February 1839 and at his Royal Society lecture on the subject in London on the 14th of March 1839 have long been amply documented and accepted as settled facts. History. Precursor technologies. Photography is the result of combining several technical discoveries. Long before the first photographs were made, Chinese philosopher Mo Dai and Greek mathematicians Aristotle and Euclid described a pinhole camera in the 5th and 4th centuries BCE. In the 6th century CE, Byzantine mathematician Anthemius of Tralles used a type of camera obscura in his experiments. Ibn al-Haytham studied the camera obscura and pinhole camera. Albertus Magnus discovered silver nitrate, and Georg Fabricius discovered silver chloride. Techniques described in the Book of Optics are capable of producing primitive photographs using medieval materials. Daniele Barbaro described a diaphragm in 1566. Wilhelm Homburg described how light darkened some chemicals in 1694. The fiction book Giffanti, published in 1760, by French author Tiffaine de la Roche, described what can be interpreted as photography. The discovery of the camera obscura that provides an image of a scene dates back to ancient China. Leonardo da Vinci mentions natural camera obscura that are formed by dark caves on the edge of a sunlit valley. A hole in the cave wall will act as a pinhole camera and project a laterally reversed, upside-down image on a piece of paper. So the birth of photography was primarily concerned with inventing means to fix and retain the image produced by the camera obscura. Renaissance painters used the camera obscura, which, in fact, gives the optical rendering in color that dominates Western art. The camera obscura literally means dark chamber in Latin. It is a box with a hole in it which allows light to go through and create an image onto the piece of paper. Invention of photography around the year 1800. Thomas Wedgwood made the first known attempt to capture the image in a camera obscura by means of a light-sensitive substance. He used paper or white leather treated with silver nitrate. Although he succeeded in capturing the shadows of objects placed on the surface in direct sunlight, and even made shadow copies of paintings on glass, it was reported in 1802 that the images formed by means of a camera obscura have been found too faint to produce, in any moderate time, an effect upon the nitrate of silver. The shadow images eventually darkened all over. The first permanent photo-etching was an image produced in 1822 by the French inventor Nice for Nie acute PCE, but it was destroyed in a later attempt to make prints from it. Nie acute PCE was successful again in 1825. In 1826 or 1827, he made the view from the window at Le Graff, the earliest surviving photograph from nature. Because Nie acute PCE's camera photographs required an extremely long exposure, he sought to greatly improve his bitumen process or replace it with one that was more practical. In partnership with Louis Daguerre, he worked out post-exposure processing methods that produced visually superior results and replaced the bitumen with a more light-sensitive resin. But hours of exposure in the camera were still required. With an eye to eventual commercial exploitation, the partners opted for total secrecy. Nie acute PCE died in 1833 and Daguerre then redirected the experiments toward the light-sensitive silver halides, which Nie acute PCE had abandoned many years earlier because of his inability to make the images he captured with them light, fast and permanent. Daguerre's efforts culminated in what would later be named the daguerreotype process, the essential elements of which were in place in 1837. The required exposure time was measured in minutes instead of hours. Daguerre took the earliest confirmed photograph of a pursign in 1838 while capturing a view of a Paris street. Unlike the other pedestrian and horse-drawn traffic on the busy boulevard, which appears deserted, one man having his boots polished stood sufficiently still throughout the approximately 10-minute-long exposure to be visible. The existence of Daguerre's process was publicly announced, without details, on 7 January 1839. The news created an international sensation. France soon agreed to pay Daguerre a pension in exchange for the right to present his invention to the world as the gift of France, which occurred when complete working instructions were unveiled on 19 August 1839. Meanwhile, in Brazil, Hercules Florence had apparently started working out a silver salt-based paper process in 1832, later naming it photography, and an English inventor, William Fox Talbot, succeeded in making crude but reasonably light, fast silver images on paper as early as 1834, but had kept his work secret. After reading about Daguerre's invention in January 1839, Talbot published his method and set about improving on it. At first, like other pre-daguerreotype processes, Talbot's paper-based photography typically required hours-long exposures in the camera. But in 1840 he created the calotype process, with exposures comparable to the daguerreotype. In both its original and calotype forms, Talbot's process, unlike Daguerre's, created a translucent negative which could be used to print multiple positive copies, the basis of most chemical photography up to the present day. Daguerreotypes could only be replicated by rephotographing them with a camera. Talbot's famous tiny paper negative of the oriel window in Laycock Abbey, one of a number of camera photographs he made in the summer of 1835, may be the oldest camera negative in existence. John Herschel made many contributions to the new field. He invented the cyanotype process, later familiar as the blueprint. He was the first to use the terms photography, negative, and positive. He had discovered in 1819 that sodium thiosulfate was a solvent of silver halides, and in 1839 he informed Talbot that it could be used to fix silver halide-based photographs and make them completely light fast. He made the first glass negative in late 1839. In the March 1851 issue of The Chemist, Frederick Scott Archer published his wet plate collodion process. It became the most widely used photographic medium until the gelatin dry plate, introduced in the 1870s, eventually replaced it. There are three subsets to the collodion process: the ambrotype, the ferrotype or tin type, and the glass negative, which was used to make positive prints on albumen or salted paper. Many advances in photographic glass plates and printing were made during the rest of the 19th century. In 1891, Gabriel Lippmann introduced a process for making natural color photographs based on the optical phenomenon of the interference of light waves. His scientifically elegant and important but ultimately impractical invention earned him the Nobel Prize for Physics in 1908. Glass plates were the medium for most original camera photography from the late 1850s until the general introduction of flexible plastic films during the 1890s. Although the convenience of film greatly popularized amateur photography, early films were somewhat more expensive and of markedly lower optical quality than their glass plate equivalents, and until the late 1910s they were not available in the large formats preferred by most professional photographers. So the new medium did not immediately or completely replace the old. Because of the superior dimensional stability of glass, the use of plates for some scientific applications, such as astrophotography, continued into the 1990s, and in the niche field of laser holography it has persisted into the 2010s. Film photography. Herter and Driffield began pioneering work on the light sensitivity of photographic emulsions in 1876. Their work enabled the first quantitative measure of film speed to be devised. The first flexible photographic roll film was marketed by George Eastman in 1885, but this original film was actually a coating on a paper base. As part of the processing, the image-bearing layer was stripped from the paper and transferred to a hardened gelatin support. The first transparent plastic roll film followed in 1889. It was made from highly flammable nitrocellulose, now usually called nitrate film. Although cellulose acetate or safety film had been introduced by Kodak in 1908, at first it found only a few special applications as an alternative to the hazardous nitrate film, which had the advantages of being considerably tougher, slightly more transparent, and cheaper. The changeover was not completed for X-ray films until 1933, and although safety film was always used for 16mm and 8mm home movies, nitrate film remained standard for theatrical 35mm motion pictures until it was finally discontinued in 1951. Although modern photography is dominated by digital users, film continues to be used by enthusiasts and professional photographers. The distinctively look of film-based photographs compared to digital images is likely due to a combination of factors, including differences in spectral and tonal sensitivity with film versus linear response curve for digital CCD senses resolution and continuity of tone. Black and white. Originally, all photography was monochrome, or black and white. Even after color film was readily available, black and white photography continued to dominate for decades. Due to its lower cost and its classic photographic look, the tones and contrast between light and dark areas define black and white photography. It is important to note that monochromatic pictures are not necessarily composed of pure blacks, whites, and intermediate shades of gray, but can involve shades of one particular hue depending on the process. The cyanotype process, for example, produces an image composed of blue tones. The albumen print process, first used more than 160 years ago, produces brownish tones. Many photographers continue to produce some monochrome images, sometimes because of the established archival permanence of well-processed silver halide-based materials. Some full-color digital images are processed using a variety of techniques to create black and white results. and some manufacturers produce digital cameras that exclusively shoot monochrome. Monochrome printing or electronic display can be used to salvage certain photographs taken in color which are unsatisfactory in their original form. Sometimes when presented as black and white or single-color toned images, they are found to be more effective. Although color photography has long predominated, monochrome images are still produced, mostly for artistic reasons. Almost all digital cameras have an option to shoot in monochrome, and almost all image editing software can combine or selectively discard RGB color channels to produce a monochrome image from one shot in color. Color photography was explored beginning in the 1840s. Early experiments in color required extremely long exposures and could not fix the photograph to prevent the color from quickly fading when exposed to white light. The first permanent color photograph was taken in 1861 using the three-color separation principle first published by physicist James Clerk Maxwell in 1855. Maxwell's idea was to take three separate black and white photographs through red, green and blue filters. This provides the photographer with the three basic channels required to recreate a color image. Transparent prints of the images could be projected through similar color filters and superimposed on the projection screen. An additive method of color reproduction. A color print on paper could be produced by superimposing carbon prints of the three images made in their complementary colors. A subtractive method of color reproduction pioneered by Louis Ducos du Hauron in the late 1860s. Russian photographer Sergei Mikhailovich Prokudin-Gorsky made extensive use of this color separation technique, employing a special camera which successively exposed the three color-filtered images on different parts of an oblong plate. Because his exposures were not simultaneous, unsteady subjects exhibited color fringes, or, if rapidly moving through the scene, appeared as brightly colored ghosts in the resulting projected or printed images. Implementation of color photography was hindered by the limited sensitivity of early photographic materials, which were mostly sensitive to blue, only slightly sensitive to green, and virtually insensitive to red. The discovery of dye sensitization by photochemist Hermann Vogel in 1873 suddenly made it possible to add sensitivity to green, yellow and even red. Improved color sensitizers and ongoing improvements in the overall sensitivity of emulsions steadily reduced the once prohibitive long exposure times required for color, bringing it ever closer to commercial viability. Autochrome, the first commercially successful color process, was introduced by the Lumiere brothers in 1907. Autochrome plates incorporated a mosaic color filter layer made of dyed grains of potato starch, which allowed the three color components to be recorded as adjacent microscopic image fragments. After an autochrome plate was reversal processed to produce a positive transparency, the starch grains served to illuminate each fragment with the correct color and the tiny colored points blended together in the eye, synthesizing the color of the subject by the additive method. Autochrome plates were one of several varieties of additive color screen plates and films marketed between the 1890s and the 1950s. Kodachrome, the first modern, integral tripack color film, was introduced by Kodak in 1935. It captured the three color components in a multi-layer emulsion. One layer was sensitized to record the red-dominated part of the spectrum. Another layer recorded only the green part and a third recorded only the blue. Without special film processing, the result would simply be three superimposed black and white images, but complementary cyan, magenta, and yellow dye images were created in those layers by adding color couplers during a complex processing procedure. Agfa's similarly structured Agfa Color Noi was introduced in 1936. Unlike Kodachrome, the color couplers in Agfa Color Noi were incorporated into the emulsion layers during manufacture, which greatly simplified the processing. Currently available color films still employ multi-layer emulsion and the same principles, most closely resembling Agfa's product. instant color film, used in a special camera which yielded a unique finished color print only a minute or two after the exposure, was introduced by Polaroid in 1963. Color photography may form images as positive transparencies, which can be used in a slide projector, or as color negatives intended for use in creating positive color enlargements on specially coated paper. The latter is now the most common form of film color photography owing to the introduction of automated photoprinting equipment. After a transition period centered around 1995 to 2005, color film was relegated to a niche market by inexpensive multi-megapixel digital cameras. Film continues to be the preference of some photographers because of its distinctive look. Digital photography. In 1981, Sony unveiled the first consumer camera to use a charge-coupled device for imaging, eliminating the need for film. The Sony Mavic. While the Mavic saved images to disk, the images were displayed on television, and the camera was not fully digital. In 1991, Kodak unveiled the DCS-100, the first commercially available digital single-lens reflex camera. Although its high cost precluded uses other than photojournalism in professional photography, commercial digital photography was born. Digital imaging uses an electronic image sensor to record the image as a set of electronic data rather than as chemical changes on film. An important difference between digital and chemical photography is that chemical photography resists photo manipulation because it involves film and photographic paper, while digital imaging is a highly manipulative medium. This difference allows for a degree of image post-processing that is comparatively difficult in film-based photography and permits different communicative potentials and applications. Digital photography dominates the 21st century. More than 99% of photographs taken around the world are through digital cameras, increasingly through smartphones. Synthesis photography. Synthesis photography is part of computer-generated imagery where the shooting process is modeled on real photography. The CGI, creating digital copies of real universe, requires a visual representation process of these universes. Synthesis photography is the application of analog and digital photography in digital space, with the characteristics of the real photography but not being constrained by the physical limits of real world. Synthesis photography allows to get away from real photography.